In this video, we're going to look at left to right addition, and we'll look at it with 3-digit numbers. Now, as I work through these, this might look a lot like the typical long addition strategy here, but really we're going to be looking at this in terms of place value starting at the left and working to the right. And as you write our answers here, you'll see the way we're stacking is a little bit different than you might do with the typical long addition method. So, and just to compare the two, I'm going to write the long addition method over here, right? And we'll solve that next. And we'll just look at how these two approaches compare. And then I'll talk about why I think it's so important to try the left to right technique. Okay, so left to right. What do? Well, first we add 500 and 300, and that's 800. Next we add 30 and 20, and that's 50. Notice I'm writing these just one after the other. And last I add 6 and 6, which is just 12. And now I add these up to get 862, and that's my answer. Working the typical approach, we add 6 and 6 to get 12. Put 2 here and 1 there. Instead of writing 12 as I did right here, we kind of split it up. Now the 3 and the 2, it's really 30 and 20, and then we add another 1, that's 6. And then we add 5 and 3 to get 8. Okay, so here's the typical algorithm, and here's my left to right algorithm where we're stacking each place value one after another as separate parts. Now, the advantage of the long addition method I think is obvious because it's really compact, right? It's all neat. The problem with the long addition method is it encourages you to think or to lose track of what these numbers really are. People often say 6 and 6 is 12, so we put a 2 here and a 1 there. Then you think 3 and 2 is 5, plus 1 is 6, and then 5 and 3 is 8. But really, this is not 5 and 3, this is not 3 and 2, that's not a 1. This 5 and 3 are hundreds. These are tens, and this little 1 up here is another 10. So long addition, a major problem with it, is that it leads us to forget, or encourages us to forget about our number sense. The opposite is true here with left to right addition. So not only does it give us this number sense, right? Because you have to think, oh, 5 and 3 is really 500 and 300, and then we write it out as 800. And then we think, oh, 30 and 20 is 50, and then 6 and 6 is 12. So it encourages us to really think about what these numbers mean, and then to write them out fully as parts of a sum. It encourages us to think about that place value. It also teaches us to break numbers apart. So I'm recognizing that 862 is breakable, right? You can decompose it into these three parts. It also allows us to estimate. So right away, what I mean is that with the long addition method, all you're doing, you're starting with the smallest place value and adding 6 and 6. But here, right, you're starting with the largest place value. So it encourages us to estimate. What I mean is that by adding the largest place value, we know this sum has to be above 800 because we add the largest place values first. So this method encourages us to think about what the answer is right from the start. So in the next couple of videos, we're going to try this method and write it out and think about it and practice with it because I think it has some major number sense advantages which will carry into higher mathematics. All right, thanks.